Hello friends, in the last lecture we discussed normal stresses and bending stresses and also took some good examples of normal stresses and combined normal and bending stress. In this lecture we will discuss the effect of transverse shear load, that is shear stress. Let's write it down. The effect of transverse shear load or shear stress. We know that when a load is applied along to a transverse axis and passing through the axis is called as TSL. This load is also parallel to the cross-sectional area of the section. We can understand it in more detail by the diagram shown in the figure. In the figure shown, the load P is also parallel to the cross-section. The area of the section, let it be cross-section area as A. Hence, the stress developed due to the TSL is called as shear stress or direct shear. The notation used for shear stress is tau. Let's write it down. And mathematically, tau is equal to P upon A. According to the type of action, shear stresses is of two types. One is single shear and double shear. Let's deal with it one by one. Let's go for single shear. Depending upon the type of connection, a connecting element that is bolt, rivet or pin may be subjected to a single shear or double shear. A single shear is a connection where there is single plane on which the shear stresses acts to transfer from one member to the adjacent member. In this diagram, two plates of equal thicknesses T is connected by a rivet as shown in the figure. As we can see from the figure 2, a resisting force V is acting on the rivet section. Hence, the shear stress is rivet. Hence, tau is equal to V upon A, which is equal to P upon A. And please remember, this is for the static equilibrium. Also, A is equal to area of the cross section of rivet, which we can see in figure 3. The pin of pliers is an example of a single shear connection. Another example of single shear stress is two plates with a lap joint or lap splice we can see in the figure. In the first figure we have a lap slice, and in the second figure we have an average shear stress which is having its own distribution. Average shear stress on splice is nothing but tau average, which is equal to V upon A, which is nothing but P upon Ls into W. The above value of direct shear stress is average because we are considering the whole area by assuming uniform stress distribution. The single stress developed as a result of the direct action of the load trying to cut through the material. Therefore, it is also known as direct shear stress. Hence, we can say that shear stress is nothing but direct shear stress or direction shear stress. Shear can also be developed by indirect action as a result of tension, torsion or bending of a member. Now, let's go for some examples. In example 1, it says that for a 12 mm diameter rivet shown in a riveted joint below, determine the average shear stress in the rivet. Let's go for the solution, students. Let's write down the solutions. Tau is equal to P upon A, where A is the riveted area. A is equal to pi d square upon 4, where diameter is given to us as 12 square. The whole upon 4. The answer comes out to be as 113.04. Now, tau is equal to 35 into 10 to the power 3, the whole upon 113 plus 0.4. Hence, while writing it out, we write it as tau is equal to P upon A, where P is equal to 35 into 10 to the power 3, the whole upon 113.04. 113.04 is the area. The answer comes out to be as 309.62 megapascal. This is our answer for the question. Next, find out the shear stress in a pin as shown in the figure. We have given the diameter of the pin as 25 millimeters. Let's check out the solutions. Tau is equal to P upon A, where A is equal to the pin area. A, as we know, is pi into d square the whole upon 4, where d is given to us as 25 square the whole upon 4, which gives the answer to be as 491. Now we can write down tau is equal to 50 into 10 to the power 3 the whole upon 491, which turns out to be as 102 megapascal. Hence, the shear stress in a pin is equal to 102 megapascal. Now let's discuss double shear. Double shear is nothing but a connection where there are two planes on which a shear stress acts to transfer from one member to the adjacent member. Let's write it down. It is nothing but a connection where there are two plates on which shear stress acts to transfer one member to the adjacent member. From the figure shown, we can see that the shear force is acting in two planes above and below the plate which is having a thickness B. The shear stress developed is called as double shear stress, and the average shear stress on a plane T average or tau average is equal to P upon 2A. The example of a double shear double lap joint in welding. This is showing us the example of a double lap joint in a welding. Let's go for example number 1. Find out the shear stress in a pin shown in the figure. The diameter of the pin is 25 mm. Let's go for the solution, students. The solution says that the pin at A is in double shear with a total force equal to the force exerted by the boom AB. Tau is equal to P upon A. We know that A is nothing but the pin area. First, we have to find out the area, where area is equal to pi d square upon 4, which is equal to pi into 25 square upon 4, which gives out the answer as 491. Now, if we go to the formula, tau is equal to 40 into 10 to the power 3 the whole upon 2 into 491, and the answer comes out to be as 40.7 megapascal. Next, we go for example number 2. For the 12 mm diameter bolt shown in the bolted joint below, determine the average shear stresses in the bolt. Let's go for the solution. Again, we know that tau is equal to P upon 2A, where area for the riveted area. Or we can say that A is nothing but the riveted area. Hence, we know that A is equal to pi d square upon 4, which is equal to pi into 12 the whole cube upon 4, which is equal to 113.04. Now, tau is equal to 35 into 10 to the power 3 the whole upon 2 into 113.04, which is equal to 154.32 megapascal. Hence, the average shear stress is nothing but 154.32 megapascal. That's all for today, folks. Thank you very much.